In this unit, you will learn how to describe an object's motion. You're going to learn several methods to describe the motion and apply them in different situations. Section 12.1 is all about distance and time, and we're going to start by learning some definitions and some abbreviations for some words you can use to describe motion. Distance, which is abbreviated with a lowercase d, is the space between 2 points. The space between 2 points, and is usually measured in meters. So usually in meters. And meters is abbreviated with a lowercase m. Time, with abbreviation of t, is the duration of an event. So the duration of an event. And time can be measured in seconds, which is abbreviated with an S. Can be measured in minutes, which is abbreviated MIN. Hours, which is abbreviated H, or days. Time interval, which is delta t, is the change in time. Period, which is abbreviated capital T, is the time interval between two repeating events. So time interval between two repeating events. For example, the cycling of a pendulum back and forth, the amount of time that it takes to go there and back would be the period. So if I was going to draw that, it's going to have to be attached to something, and then this is a string coming down with whatever the mass is on the end, and it can, if you held this out there and you released it, it would swing across until it reached some point over here. And the time that it took to go there and back would be one cycle, so it would be one period. Frequency is the inverse of period. Frequency is symbolized lowercase f, and it's the number of cycles that occur in a given amount of time. So the number of cycles that occur in an amount of time. And frequency is most often measured in hertz. And hertz is abbreviated Hz. The formulas, period and frequency are related. Period equals 1 over frequency, and frequency equals 1 over period. We're going to look at a couple sample problems. First of all, if you had a pendulum and it swings 12 times in 8 seconds, what is the period and what is the frequency? Well, the period, t, is the time, 8 seconds, over the amount of swings, 12 swings. So it's 0.67 seconds. So it's 0.67 seconds per swing, the amount of time it takes to happen once. Frequency is 12 swings, it's the opposite, 12 swings take 8 seconds. And that's going to give us 1.5 hertz, or you can think of that as 1.5 swings per second. You're going to be doing a lot of graphing in this unit, and so you need to be familiar with graphing and the slope of a line. So you need to know that slope equals rise over run, which equals y2 minus y1 over x2 minus x1. And if we had an example, if I just drew a simple graph here, let's make it distance versus time. So we're going to have seconds on the x-axis, and we're going to have distance in meters on the y. And let's make just a few intervals here, 1, 2, 3 meters. And maybe we'll make a slightly different scale. We won't just go up by 1, but let's say 2, 4, 6, 8 seconds. If we made a nice linear graph here, a nice straight line like this. I would have used a ruler and connected that, it'd be nice and straight. We can choose any two data points on here. When you're trying to figure out the slope of a line, you can choose any points on it. So I'm just going to choose this one and this one. So then we want to do the slope. So y2 minus y1 over x2 minus x1. y2 is here, is 3. So 3 minus y1, which is 1, over here, the x is 6, minus the x here is 2. So we're getting 3 minus 1 is 2, over 6 minus 2 is 4. 2 over 4 equals 0.5. So the slope equals 0.5 meters per second. Try the sample problem here. Try and figure out what the slope of the line is for these 2 points. You should solve this and get an answer of 4, so a slope of 4. We're going to be doing this lab at some point in class, so we'll come back to the equation of a line then when we look at that. Now we're going to switch over to 12.2. 12.2 is all about speed, and speed is the rate at which an object travels. So, oops, turn the pen on. Speed is the rate at which an object travels. So we can say it's the distance it moves in a given time interval. To write this as an equation, speed equals distance over time. So speed equals the change in distance over the change in time. And the symbol for speed is a lowercase v. So put that there. Because vehicles often don't travel at a constant speed, what we're calculating when we do a calculation is the average speed. So this is the total distance divided by the total time. So average speed and that would be abbreviated speed average equals the change in distance over change in time. And that could be your final position minus where you started over your final time minus the time when you started. We are going to be doing several practice problems in class, so we'll come back to these sample problems. Just a couple more definitions. We looked at average speed. Now we're going to look at instantaneous speed and constant speed. Instantaneous speed is the speed at any given instant. So the speed that an object has, or the speed of an object at a particular instant in time. For example, if you're given a speeding ticket, you're getting a ticket for your instantaneous speed. Constant speed, an object is going to have constant speed. If it's instantaneous speed, it's the same as its average speed. So an object will have constant speed if its instantaneous speed is equal to its average speed. We will be doing some practice questions and some CYUs in class, so you can cross off any CYUs it has written here at the bottom.